back. Today we're going to talk about solving equations using strictly multiplication and division. Later we're going to talk about putting it all together, but today just multiplication and division. The multiplication property of equality says we can multiply by the same thing on both sides. And the key to this is, once again, you must do the same thing to both sides. You must do the same thing to both sides. You must do the same thing to both sides, because if you don't do the same thing to both sides, you tip that scale of the equation. So x over 3 is equal to 4. Well, I'm going to undo that division by 3 by multiplying by 3, but I also have to multiply the other side by 3. If you have 100 pounds of gold on this side and 100 pounds of feathers on this side, and you multiply by 3 to get 300 pounds of gold, you need 300 pounds of feathers to even it out. And so this is the multiplication property of equality. I can multiply by the same thing on both sides in order to keep the scale balanced. What does this look like? We're going to solve using multiplications. We're going to solve the equations using the multiplication property of equality. Once again, my goal is to get variable by itself. And here's our steps to do that. Number 1, we make 0 pairs. Here's a hint. We're not going to use this one right now. And number 2, we're going to do opposite operations. Opposite operations are operations that undo one another. Well, multiplication undoes division. If I divide a pizza in half and then I multiply by 2, it's the same as undoing it. And so in this equation, I want to get y by itself. This is what I want by itself. Well, what happens is we're dividing that y, whatever it happens to be, by 3. Well, we're not adding anything, which would be the 0 pairs, and so I'm really not going to do this on this problem. Later I will, but I'm not going to do it here. And so I need to do opposite operations. Well, I want to multiply by 3 because that undoes division. Opposite operations. But to keep it balanced, I must do the same thing to both sides. I must do the same thing to both sides. I must do the same thing to both sides. So if I multiply by 3 on one side, I have to multiply by 3 on the other side. I knew to multiply by 3 because I'm doing the opposite operation of dividing. So now I'm left with y by itself is equal to 5 times 3, y equals 15. If I wanted to check, I could say 15 over 3 equals 5. It checks out. So you see how this works. Let's do another one. They switched it around, but we're not scared because our goal is still the same. Goal: get x by itself. And my steps: 0 pairs. And opposite operations. Okay? Well, I have no 0 pairs in this one because I can't add or subtract anything to get 0. But I'm going to do opposite operations, so I'm dividing by 9. So to do that, opposite operation, I'm going to multiply by 9. Those now cancel out. I divide the sum by 9 and multiply by 9 to undo that. But I must do the same thing to both sides. I must do the same thing to both sides. I must do the same thing to both sides. You guys thought I forgot. Must do the same thing to both sides. So now on the right side, I am left with x, and I'm going to do 9 times 21. A quick way that I remember it in my own mind is 9 times 20 plus 9 times 1. It's 9 times 20 plus 9 times 1. Well, that's 180 plus 9 is 189 equals x. That's my answer. Because if I plug it back in, is 21 equal to 189 over 9? The answer is yes, a resounding yes. The other half of this is the division property of equality. I think you can see where we're going with this. If I have 2x equals 24, I want to do the opposite operation. Well, if I'm multiplying by 2, I'm going to do the opposite operation and divide by 2. Opposite operation. That's an opposite operation because it's undoing or doing the opposite of multiplying. But you must do the same thing to both sides. You must do the same thing to both sides. You must do the same thing to both sides because if you do it to one side, it has to stay balanced using division. In this case, we're still going to use 0 pairs. If there are any available, well, you can see in the problem that there are no random numbers being added or subtracted. So I'm really not going to use this. Instead, I'm going to go to step number 2. Opposite operations. So, if I'm multiplying x by 4, which is what 4x means, to do the opposite of that, it's going to be division by 4. And I'll have to divide the other side by 4 because I must do the same thing to both sides. I must do the same thing to both sides. I must do the same thing to both sides. And so when I divide 4x by 4, I simply get x. If you give me $4 and I divide it by 4, it's $1. I want 1x because my goal is to get x by itself. X equals 5. I plug it back in. Is 4 times 5 equal to 20? The answer is a resounding yes, it is. Now that you've seen a couple of these, why don't you try this one on your own? Remember, we're going to do 0 pairs, then opposite operations. Hint, there are no 0 pairs. Okay? So do opposite operations to solve this one. Write this one down because I'm going to skip to a second example here. Here's another one. I would like for you to try this one on your own as well. It's a negative number, but don't be scared. Now, a word problem, and then we are done. A teacher divided a class into 4 teams with 6 students per team. Write and solve an equation for the size of the class. Well, what don't we know? We know that when we divided the groups, there were 6 in each group. Well, I divided it into 4 groups, but my number of students, I don't know. I don't know the number of students. And so this is going to be my equation. Some number of students that I don't know, x, divided into 4 groups, or teams, with 6 students per team, is going to give me my answer. So go ahead and solve that one on your own. Thanks for watching, guys. Remember, do those 0 pairs and those opposite operations, and it's all going to be good. We'll see you next time.